Okay, so what we're going to do today is make Sodium-Potassium Hexanitrocobaltate. It's also called Sodium-Potassium Cobalt Nitrite, but I prefer the Hexanitrocobaltate. It just sounds kind of cool. Anyway, we'll need only 3 things to make it, and that is, besides distilled water, we will need sodium nitrite, cobalt sulfate, or any real soluble cobalt compound, and glacial acetic acid. Yay! An interesting property that you can see with cobalt salts is their paramagnetism. This means that they're attracted to a magnet, but not themselves, magnetic like a magnet. We can see this by holding a neodymium magnet, very strong magnet, near the cobalt sulfate, and you can see I didn't even touch it, and there's cobalt sulfate sticking to the magnet. The magnet's not wet or anything, it's completely dry. As you can see, but the cobalt sulfate is attracted to it. That is because it is paramagnetic. Alrighty, so now we can go ahead and add water, distilled water, to a beaker and begin to dissolve our cobalt sulfate or cobalt salt in this. From here, we are going to further acidify the solution using an acid. Here, I'm using glacial acetic acid. That should be about good. Now, dissolve sodium nitrite in more distilled water. This is going to be a separate solution in a separate beaker that we are not going to combine quite yet with the acidic solution. Once you've added your sodium nitrite, go ahead and set it off to the side and bring back your beaker of cobalt sulfate and acid. Now, with our cobalt sulfate and acid solution back in the original beaker, we can go ahead and slowly add with a dropper, pipette, or whatever. We can go ahead and add our sodium nitrite solution. This will form the complex, and we'll see that as a dark color, probably about a orange, brown, yellow color. Now become more apparent the more you add. Don't add it too quickly or else you will start generating nitrogen dioxide, which, trust me, you don't want. As we can see, the color is beginning to darken, indicating that our complex is forming. Anyway, what we're going to do now is continue adding sodium nitrite until the color stays a nice dark yellow orange color. If the solution gets too warm or too much nitrogen dioxide begins to come off, you can throw in an ice cube or two or set it in an ice bath. If a small amount of our reaction solution is taken up in a pipette and diluted with some water, the yellow color of the complex can be seen much more easily. Very nice. Whoops, I also forgot to mention you will need potassium chloride for this. Now, to a 500 milliliter beaker, I'm going to add roughly 300 milliliters of boiling distilled water. To this 300 milliliters of boiling distilled water, I'm going to add approximately 1 metric shitload of potassium chloride. To our concentrated potassium chloride solution, we can now add our solution of sodium hexanitrocobaltate. This will form a precipitate a very vibrant yellow precipitate of Sodium-Potassium Hexanitrocobaltate, which we will observe right now. With all of the solution added, we can now see we have a very large amount of our precipitated complex. Now what we're going to do is simply filter it and then dry the product. Gravity filtration here is practically required. The precipitate of the complex is in a very fine form. It will even pass through multiple filter papers here, so I mean there's nothing you can do to really catch all of it unless you have some sort of absolutely mental filtering setup that can catch everything. But I mean, it's not a large amount that makes it through, but you know, it's still some. It should the amount that comes through the filter should decrease after a while, but you will catch probably 95 to 98% of the product in the filter. What you can do after it's all done filtering is put it on top of a few folded paper towels to let it air dry for probably a day or two. It dries pretty quickly and sort of shrinks a little bit, so it's a lot easier than some things to scrape off the filter paper. Here's the final material. Potassium sodium hexanitrocobaltate, also known as potassium cobalt nitrate. I really hope you enjoyed. You can like and subscribe if you want to. And thank you very much for watching. I'll see you guys next time. I'll try very hard to get another video out pretty soon. Not really sure as to what it will be, but I will let you guys know. So check my Twitter for updates, as well as my Discord, and the Explosions and Fire Discord, because I'll probably leave most of the information there. See you next time.